Okay students, so moving on to the next section, we have match the column type questions. Question number 56 A part says that the positive value of x which satisfies the equation x power 4 minus 2x square multiplied by sine square of pi x by 2 plus 1 is equal to 0 is. So P says less than 2, Q is equal to 1, R is greater than 1, S is equal to 0, T is less than 5. So students, let us solve this trigonometric equation. X power 4 plus 1 is equal to 2x square sine square pi x by 2. Dividing by x square on both the sides, I have x square plus 1 by x square is equal to 2 times sine square pi x upon 2. X square is always a positive quantity. So in left hand side we can apply AMGM inequality. So left hand side is clearly greater than equal to 2. And for the right hand side the maximum value is 2. Okay. So RHS is less than equal to 2. No doubt it is greater than equal to 0. Fine. So that means the solution is only possible when LHS is equal to RHS is equal to 2. So LHS is equal to 2 when x equals 1. RHS is also equal to 2 when x equals 1. So x equal to 1 is the only solution for this equation. We have P correct, Q correct, T correct. So A matches with PQT. Okay. Let us move on to B part. B part says that the number of solutions of the equation x square plus 2x plus 2 secant square pi x plus tan square pi x equals 0 is. So students, we have to create the perfect squares. X square plus 2x plus 1 plus secant square of pi x can be written as 1 plus tan square of pi x. So 2 plus 2 tan square pi x plus tan square pi x and minus 1 because I had added 1 in the first part of the equation. So this is x plus 1 whole square plus 3 tan square pi x plus 1 equals 0. This is never possible because this is always greater than equal to 0. This is always greater than equal to 0. So sum of these three quantities can never be equal to 0. So we have no solution, which means that the number of solutions is 0, which is less than 2 and less than 5 and equal to 0. So B matches with P, S and T from the column 2. Okay, let us move on to C part. C part says that for x belongs to minus pi to pi open interval, the number of solutions of the equation root 3 sin x plus cos x whole raised to the power under root of root 3 sin 2x minus cos 2x plus 2 is equal to 4. Students, let us assume it as a raised to the power b first of all. Okay, so what is a? A is root 3 sin x plus cos x, which can be written as 2 into root 3 by 2 sin x plus 1 by 2 cos x, which is simply 2 times sine of x plus pi by 6. So students, A is a quantity which belongs to minus 2 to 2. B, the value of B is under root of root 3 sin 2x minus cos 2x plus 2. So what are we going to do? We are going to write it as 2 root 3 sin x cos x 1 minus cos 2x is 2 sin square x. So 2 sin square x plus 1, that means 3 sin square x plus cos square x. So I have written 1 as sin square x plus cos square x whole under the root. So this is clearly equal to mod A. Okay. So B is also further equal to mod A. A belongs to minus 2 to 2. A power B is equal to 4. So only possibility is A equals 2. Okay. So if A is equal to 2. So students, this is ultimately equal to mod A and we have A power B equals 4. That means mod A is equal to 2. Because 2 raised to power 2 is also 4. Minus 2 raised to power 2 is also 4. So solving mod A is equal to 2. I have sine of x plus pi by 6 mod is equal to 1. Okay. So we have two values of x lying in the interval minus pi to pi. Those two values will be, one is directly pi by 3 and the other one is minus 2 pi by 3. Okay. So these are the two values. Number of solutions is equal to 2. Number of solutions is equal to 2. We have greater than 1 and less than 5. So C matches with RT from column 2. Okay, let us move on to D part. For D part, equation sin x plus cos of k plus x plus cos of k minus x equals 2 has real solutions, then sin k can be. Students, this is sin x plus cos of a plus b plus cos of a minus b. So this is 2 cos a cos b equals 2. Now students, left hand side is in auxiliary format. A sin x plus b cos x, a is equal to 1, b is equal to 2 cos x. So the left hand side will belong to minus under root of 4 cos square k plus 1 to plus under root of 4 cos square k plus 1. So students, this will have a solution only if 2 is less than equal to root of 4 cos square k plus 1. So cos square k greater than equal to 3 by 4, sin square k less than equal to 1 by 4. So sin k can be. So from here I can see that sin k belongs to the interval minus half to half. So P is correct, Q is wrong, R is wrong, S is correct, T is correct. So P, S, T is the correct match for D option. Okay, let us move on to question number 57. Question 57, which is based on probability, it says that in a tournament there are 8 players P1, P2, P3 up to P8 and divided into 4 pairs at random. From each game, a winner is decided on the basis of a game played between the 2 players of the pair. Assuming that the players are of the equal strength, then match the following. स्टूडेंट्स, हमारे पास 8 प्लेयर्स हैं, 8 प्लेयर्स की 4 टीमें बनेंगी, 4 टीमों के बीच में एक एक मैच होगा. अल्टीमेटली हमारे पास क्या आएंगे? 4 विनर्स और 4 लूजर्स. Question number A says that probability that P2 is among the losers. Okay, so it is directly equal to half because all the pairs are to be assumed of equal strength. So either P2 will lose or P2 will win. Okay, so P is wrong, Q is correct, R is correct, 2 by 5 is less than half, so wrong. This is also wrong. A matches with QR only. Okay, let us move on to B part. B part says that under the same rules, probability that P2 and P4 are among the winners. Students, this probability of event E is governed by 2 facts. First fact, P2 and P4 should not be in the same team, because if they will be in the same team, one of them will win, the other will lose. Because both of them have to be winners, that means I'll do 1 by 2 into 1 by 2 into P, where P is the probability that they are not in the same team. So let us calculate P. P can be written as, there are 4 teams to be made. Let us say P2 is in the first team. This is P2. So for P4, there are 6 favorable cases. 1, 2, 3, 4, 5, 6. So P is directly equal to 6 upon 7, where 7 are the total number of empty places. Okay, and this is going to happen for each of the permutations of P2 and P4. So the final answer of this event will be 1 by 4 into 6 by 7, and that will be 3 upon 14, approximately equal to 0.21. So we have the final answer as 0.21. P is wrong, Q is correct, R is wrong, S is correct, T is correct. So B matches with Q, S and T. Okay, so you have to consider the case very particularly. The first event, that is, should not be in the same team, multiplied by the corresponding probability of their winning by being present in different teams. Okay, let us move forward to C part. Question number C says that probability that P4 and P5 are not playing against each other. We have already calculated this one, because no matter what is the number of players, they will play against each other by the probability 1 by 7. They will play against each other by the probability 6 by 7. This has already been discussed in part number 2. Greater than half, correct. Greater than or equal to 1 by 4, correct. C matches with PR. Let us move on to D part. Probability that exactly 1 out of P3 and P4 is amongst the losers. So exactly 1 should be among the losers. So 1 minus the probability that both are losers. So if both are losers, they cannot be in the same team. Again, 1 minus 6 by 7 is the probability that they will not be in the same team, multiplied by half the probability of losing of P3, multiplied by half the probability of losing of P4. So 1 minus 3 upon 14, and that means 11 upon 14 is the answer for this question. Probability of event E. Greater than half, greater than or equal to 1 by 4. So D matches with again P and R. Okay, let us move on to the next section which contains integer type problems.